Yo, what's going on guys? Rhys here from Stoic Pool, and in this video I'm going to show you how to build a water-cooled Raspberry Pi Cardano node. Let's do this. Right guys, so a lot of people have been really excited about this video. I've been really excited about this video because it's quite unique. You know, I only found 2 people who had really done water-cooled Raspberry Pis at all, and no one has done this for a Cardano node, so it's a really cool little setup. It was a really fun project, and it's meant that I have 0 costs now for running my stake pool, which is fantastic. It runs purely off solar power. It has... that's it. Yeah, that's it. Cool. I'm going to get more into metrics for the water cooling. I'm going to get into costs. I'm going to get into energy consumption. I'm going to get through all this at the end. So if you're only interested in that and you're not really worried about how it was built, just skip through to the end or sit back, put the thing on mute and just watch the build. Right, so for those who don't know, a Raspberry Pi is a tiny little single board computer. It has a 4-core processor and 8 gigs of RAM, which is just about the limit of what a node can run on anyway. To do this build, I basically got 3 Raspberry Pis. I already had one, which I was going to use to monitor it. And then I put them all on standoffs. And because I wanted to fit it into a PC case, I got an acrylic sheet of plastic cut to an ATX motherboard size so that I had something to mount it on to then put it into the case. The biggest challenge that I had initially was figuring out how to lay out the Pis and the SSD cards on the motherboard, because like there are loads of options, but I really wanted it to be aesthetically pleasing. Like I wanted it to be symmetrical and I wanted it to fit in the most organized and least chaotic way. So we took a good 2 hours to figure that out, me and my mate who helped me build it. And then realistically, it was just getting on with the build. So we put the motherboard into the case and then we laid out all the Pis and the SSDs where they were going to go. And after a little bit of discussion and fiddling things around, we were happy with the layout. We marked out all the standoffs with a Sharpie so that we could see where all the holes needed to go to fit it into the case. Then we marked all the holes for the standoffs for the Pis and the SSD cards so that we could drill all the holes in one go. The holes for the case are 5mm, the holes for the standoffs for the Pis and the SSDs were 2. So we had 2 different size holes to drill, but once they were marked, it was literally as simple as just attacking it with a drill, and then that was done. The next step was to remove everything from the case that wasn't necessary so that we had access to all the holes in the case so that we were left with just a shell to work with. I didn't want anything in the way of potential cable routes or anything like that. I wanted to know that I could access every part of the Pis and the motherboard without any issues. So we took everything out of the case and fitted the Raspberry Pis and the SSDs onto the motherboard, and then once we had everything in place, it was just a case of screwing it into the PC case. The SSDs themselves had little stickers over the chips, and so we had to remove them so that we could fit the water cooling unit and the heat sinks to the NAND gates. So we took them off, we gave them a little wipe down with isopropyl alcohol to make sure they were quite as clean as could be before fitting them to the motherboards. Once we had the computers in place, the next thing was really just to fit the water cooling loop. We needed this all in place so that we could test the loop before we plugged everything in, because that gives us a chance to rectify any issues with leaks, make sure we have everything routed properly without anything else getting in the way. So we fitted the fans to the radiator for our all-in-one CPU cooling unit, and once we got that, we screwed it into place in the case. Once we decided which way round to orient the radiator, we knew how high or low we had to fit the reservoir and the pump so that they didn't interfere and gave us enough room to work with a very short bit of hosing to connect the two together. We didn't want to use any more hosing than was absolutely necessary. We wanted everything to be nice and tight and fitted and neat. Once we had all these in place, the first point of action was to route the hosing for the Pis and the SSDs. So we need to reduce the hose from a 16mm to an 8mm to be able to actually water cool the Pis. So we fitted a little reducer onto the end of a very short bit of hose with some compression tubes and screwed it into place on the outlet of the pump. The next thing is to put all the cooling units onto the processor chips of the boards and the SSDs. So we gave it another wipe down with isopropyl alcohol. We fitted some thermal pads to the units and then fitted them into place. Once they were all on and we were happy with how they were routed, all we had to do was cut the hose down to the right size and plug it all in. It was at this point that we actually realized we couldn't use an all-in-one CPU cooling unit for like a normal PC because you can't remove the hosing from the radiator. So we had to put the whole build on hold for a week whilst we waited for a replacement radiator to come so that we could actually complete the loop. One thing that was really important during this build was that everything was symmetrical or as neat and tidy as could be. And we went a little bit overboard on this by even making sure that the hosing all came off the same distance from the board. And if that meant we had to cut stuff down a little bit shorter or cut a whole new length of hose to get that right, then that's what we did because we wanted it to look perfect when it was done. A week later, Radiator had arrived, and so we removed all the fans from the all-in-one unit and put it onto our new custom loop radiator. Once we had the fans in place, we removed the plugs from the end of the radiator and screwed in the compression fittings ready for the hosing. Then it was just a case of screwing the radiator into the case, making sure it was fitted properly, and then we could continue with the water cooling loop. We had to decide at this point which outlet of the radiator was going to feed the reservoir and which one was going to be the end of the Raspberry Pi loop, because we needed to fit another reducer to bring the 8mm hose back up to a 16mm hose before it goes into the radiator. The side we chose all depends on what routes from the radiator into the reservoir the easiest. We decided to fit the furthest one in because it had created a nice little S bend in the bigger hose. It was the neatest solution, and so it just made sense to have it that way around. It also looks better from outside the case now it's completely built, and I'm really happy with how that turned out. We plugged the last little bit of hose from the final SSD into the reducer, and then the water cooling loop was complete. All that was really left to do now was to test it. So we got our distilled water with a little bit of biocide in, we filled it into a filling container, and we stuck the little straw into the reservoir and filled it up. Once the water was in the reservoir, we turned the pump on, left it for half hour, and then came back to check for leaks. Now, we did actually discover that we had a leak whilst we did this, and it took another 2.5 hours of tightening stuff up, turning the pump back on, giving it a bit 20 minutes to kind of run and see if the leak was fixed before we were happy with the security of the water loop. No one wants leaks in their PC build, and this was no exception. We're lucky actually that the water loop was leaking where it was because it was only going down onto one of the fans and it wasn't putting any of the computer parts at risk. Whilst the pump was running, we fitted all of the heat sinks onto all the other chips on the SSDs and the Raspberry Pis. And this is just a case of wiping everything down with isopropyl alcohol again and attaching a little bit of thermal paste to some very, very small heat sinks and then gently fitting them into place. We attached heat sinks to the 2 NAND chips on the SSDs, and then we took the 2 biggest chips on the Raspberry Pis, which are the most common ones that attach to heatsink cases, and we attached heatsinks to them. We then left the pump running overnight to give one last check just in case the leak wasn't quite fixed. And when the morning came, we were very happy with how it had turned out, and so the next stage was really just to start plugging everything in. Plugging in the Pis involves a network switch, it involves power supplies, there are Ethernet cables going everywhere, there are power cables, and there are cables connecting the Raspberry Pis to the SSDs. We've got an 8-port network switch that we were going to put into the back. But before we could do that, we had to remove all the bits from the case again just to prevent anything from getting in the way of us routing the cables. We needed to route everything and then close the case up again to make sure that we had everything nice and neat and organized and we weren't working around things unnecessarily. The most important thing is the power connections. the power is going to be taken from outside of the case for all the Raspberry Pis, and the power cables go from each power cable goes from a different direction on the board. So we needed to put a power cable in through the top, through the bottom, through the left, and through the right of the board. Luckily, this case has plenty of holes to actually enable this routing to go. And once we had those in, the next stage really was to plug in the SSDs to all the Raspberry Pis. The Ethernet cable wasn't too much of an issue to fit, so once we had all these in place and I was happy with the layout, then we can move on to the Ethernet. Just with my OCD with the water cooling loop, I really wanted the cables to fit nice and neatly into the case. So they all needed to be routing out symmetrically. All the cables needed to protrude through the case the same distance. And all these things, although very, very small, they make a massive difference to the finished product. And so I spent a good bit of time routing the cables and making sure everything was set to my satisfaction. Once the cables were all plugged in, it was time to spin the case round and worry about cable management. But before we actually did this, I had to make sure that the power for the pump, the lighting, the fans, everything was working correctly. So we plugged those bits in and we gave the water cooling system a final dry run before we plugged everything else in. I let the water cooling system run on the default RGB rainbow marshmallow setting for a good half hour. And while I did that, I just plugged the case back up and routing all the cables and how I was going to lay that out in the back of the case so that the pumps could run and I could give it that final little test. Cable management in any computer is an absolute nightmare, and having it actually fit neatly into the back of the case is a bit of an art in its own right. With the RGB controller for the Corsairs, I used the 3M double-sided sticky pads that come with it to fit the controller into the top of the PC case so it was well out the way. Then I just tied up all of the RGB cables and fan cables together and fitted them into the case so that it left as much space as possible for the other cables. It was cheaper to power the fans and pump off a regular PC power supply than it was to buy individual converters and power supplies for each part. So I just got a really cheap power supply unit, fitted that into the case where the power supply belongs, and it was lucky because that actually gave me a shelf to put the network switches on. Now with the Ethernet cables, I wanted them to fit into the network switch in the most logical position based on looking at the front of the case. So it made sense where all the cables were plugged in case I ever had to remove one or troubleshoot a cable or the switch itself. Then it was just a case of putting all the excess cables into the case in as neat a way as possible and fitting the backplate on to keep them all in place. Once that was done, I put the glass panels on the front and I gave it an hour to run on at full capacity whilst I had some lunch. And then it was just a case of plugging all the power supplies in and the build was complete. Now guys, there were two things that I also fitted into the system which I didn't cover in the video, and that was a drain tap. So there's a tap on the right hand side of the reservoir so that I can flush the system and then refill it nice and simply. And this is really important for water-cooled systems because if you don't have a way to take all the water out, then draining the system can be a bit of a mess. And all I did was I fitted a tap to one side, obviously left it closed, and then I have like an extra bit of hose which is about 12 inches, about a foot long, which I can then screw in with a compression fit in straight into the tap whenever I need to drain it, flip it over and take all the water out nice and quick and simple. The other thing is a thermometer so that I can monitor the water temperature over time to see if the system's heating up or if it's cooling down or what. I can monitor it basically. I also programmed the RGB so that it wasn't rainbow marshmallow, except for the reservoir. And this is a little mistake I made because I hid the RGB for the reservoir so well that I couldn't access it without taking everything out again. So I kind of missed an opportunity on that. But I'll probably take the time to dismantle the back and reroute the cables in future so that I can change the color settings for the RGB if I ever decide that I want to. Right guys, so that is the build. So now we've covered all the steps you need to do this by yourself, and we've talked about the little hiccups that I had from getting the wrong all-in-one cooling unit rather than individual parts to having a leak in the system, which was an absolute nightmare at 2:30 in the morning when we were trying to deal with it. The next thing really is to talk about costs. So initially, when I was putting this together, I kind of thought it would probably cost about £1,000. And once I started really figuring out all the parts I was going to need, because it's hard to get that information from something that has never really been done before to the same extent as what I was trying to achieve in the project. So I had to take some time to really research and figure out what parts I needed. So once I started writing everything down, I basically came with about £1,400 worth of materials and parts and bits and bobs and drill bits and all sorts. And what I didn't account for in that cost was delivery, extra bits just in case I needed them, and getting an all-in-one PC cooler and not being able to use it. So the total cost for this build was £1,525.18, and that's everything from deliveries to taxes to mistakes to bonus parts, an extra litre of water, cutting tools and drill bits, and everything. That is literally everything that I used for this build. So that's the total cost. I'm going to have a full breakdown in on the website. I'll put a link to that once I have it done. Right now it's not done, but I will put a link to that so you can look at all the parts that I used and you can build this entire system yourself if you want to. The next thing is power consumption. So initially I had a computer running virtual machines so that I had a bare metal servers and I didn't have to pay cloud computing costs, but it was using too much power. So once I realized that this was actually something that could be achieved with Raspberry Pis, based on talking to guys in the Armada Alliance, which is a community of stake pool operators who run Raspberry Pi stake pools, I really realized that this was an achievable project and then something that I wanted to do. This actually reduced my power consumption massively, and the Raspberry Pi build itself takes little to no power at all, which means I can run it purely off solar power, whereas when I had the PC with the virtual machines running the node, the power consumption was too much. So it was taking too much power, meaning that over the winter when there was less sun, or if it was like raining or particularly cloudy for a prolonged period of time, I'd be taking power off the network, and I didn't want to. I wanted to run it purely off the solar panels so that it was completely clean, renewable energy. The Raspberry Pi solved this, and a little bit of an idea about power consumption with the RGB setting on. So with the fan lights running and with the reservoir lights running, it was running off 0.334 amps. So with the RGB off, it runs off 0.276 amps. And that's at 45.9 watts, which it's a tiny amount of power. It's like such a small amount of energy from what a normal PC takes. It's crazy that is even enough power to run the thing. But what this means is it can work throughout winter. It can work it doesn't matter. It literally doesn't matter. It uses so little energy that the battery power supply that is filled up by the solar panels, it always has enough power to run the nodes, which is fantastic. So it is a completely clean energy, renewable energy source pool. We've talked about power consumption. Now the next thing is this water cooling system. A lot of people think this is overkill, and to an extent maybe it is, but I know from having Raspberry Pis that they run very hot, and I know from having the SSDs as well that they run incredibly hot. And if you're not at least running heat sinks and fans, these things have these things do run a risk of overheating and crashing as a consequence. And when I'm operating a network, I don't want that to ever be an issue. I don't want any issues with overheating in the system at all. So water cooling was a very simple solution for that. It doesn't mean that you have to water cool your Raspberry Pi Cardano nodes to have a functioning stake pool. Absolutely not. But I knew that I was overclocking. I knew I was going to be ragging these Pis for all they're worth and somehow squeezing a little bit extra out of them. So I wanted to make sure that I gave them the best opportunity to optimize their performance. And I think water cooling them has actually done that very well. So the water cooling loop covers the processor chips for the Pis and the SSDs. So we're water cooling both parts all the time. A lot of people have said I should have run the water cooling loop in parallel rather than in series, but in practice, from measuring the temperatures, it actually makes no difference. The difference between the coolest Pi and the hottest Pi is 3 degrees. And that's not even the first Pi to the last Pi. The first Pi is running at 34 degrees or 32 to 34 degrees depending on the time of day. And the furthest Pi in the loop is actually running at 32 degrees, so it's running cooler. The highest temperature I've recorded on the Pis is 36 degrees, and that was from somewhere in the middle, which makes no sense because you'd expect the last node to be running the hottest because the water goes around in a certain direction. And the only reason that I can think this has happened is purely based on silicon lottery for the chips. So the last Pi just happens to have the better quality silicon chips, so it runs slightly cooler as a consequence because it's more efficient. But the truth is there is no reason not to run this in series, and actually running them in parallel creates other issues with water pressure, and it was better just to run them in series than have any risk with water pressure and the water not flowing through the system properly. So parallel is out of the question. Series, they're running so cool, it doesn't matter even if there was a 10-degree discrepancy between the coolest and the hottest node, so it makes absolutely no difference. The last thing to cover really is just the performance of the Pis themselves, and let me just measure this. The way that I've set up these Pis is that 3 Pis are running nodes. So I have a block producer and I have 2 relays. And then there's a 4th Pi in the case, and that basically monitors the other Pis so that we save on processing power and we don't kind of detract from the ability for those Pis to run the nodes. And instead that 4th Pi monitors all those nodes and exports that data so that I can access it from anywhere. It also controls the fans and the pump, and from that, I can tell you that the Pis are running at about 30 to 35% capacity of CPU, and they're running at about 75 to 85% of their RAM, which is tiny. You'd expect it to be more. When they have more peers, they use some of the swap RAM, which is the only way that I can really guarantee that the nodes aren't going to crash out because of memory use, or like running out of memory basically, which is something that the Armada Alliance community have put together themselves. And I've got to really thank them for their Raspberry Pi build, because when I tried to do a Raspberry Pi node in the past, it didn't work because they wouldn't run the binaries, basically because they're not designed for ARM architecture. But I've got to give it to the Armada Alliance. Like, you guys, I couldn't have done this without your community. So big thanks to you. I'm really happy with this build, guys. I'm really happy that it works. Like, I'm really pleased with the design and how it's come out. Like, the finished product actually looks really good. I'm over the moon with the energy consumption, because I'm shocked at how low it actually is. I was expecting a little bit more energy than that. Like, to put it in perspective, your phone charger is like 2 amps, or is rated for 2 amps. So like I'm using a lot less power than a lot less current at least, which is just crazy. It's just craziness. I don't really have anything else to say. I'm gonna have a full breakdown of parts and costs for each of the bits on the website, which I'll have in the next couple of days. Like, I haven't got that right now because I was much more interested in getting this video out for you guys. If you have any questions or comments, just pop them in the box. I'm happy to help any of you if you're interested in doing a build like this yourself. If you're running your own stake pool and you want to make the move to a truly decentralized bare metal build, if you want to monitor the power consumption, if you guys want updates on how the pool's performing over time, I'm happy to do that. I've got a wall plug monitor for power consumption, so I'm tracking it over time. I get all the data from the solar panels, so I know exactly how much energy is being used compared to how much is being generated by the panels. Like, I have all the data on this stuff. I want to just thank the Armada guys again for helping with this, and a big shout out to the Single Pool Alliance and the Bare Metal Alliance and the eco-friendly pool community as well for everything that you guys contribute to the Cardano community. And now I'm just glad to be a part of each of those groups respectively, because I'm really doing my part for everything, true decentralization. Guys, that's it for this video. I hope that I've shared everything and answered all the questions that you had about this build. It's been a couple of weeks in the making for a few unforeseen issues that I hope, now that I've shared this video with you on the build, that you guys can avoid those mistakes and just do it nice and quick and easy, because this could be done in a weekend. It's taken me a couple of weeks to do so because of these issues. Yeah, if you have any questions about energy, power consumption, the build itself, leave those questions in the comments. If you're worried about performance of the pools, like, I'm tracking all of this data, so I'll do an update in 3 months to let you guys know how it's going through the winter, and I'll do an update in 9 months to let you know how it's operating in the summer. I am very confident that this pool is going to be working absolutely fine. I'm really happy with the build and how it's turned out. And yeah, that's really it, guys. So thanks for tuning in. Thanks for being patient. And if you have any questions, just leave them in the box below. Otherwise, give us a like. I'm about to sneeze. Otherwise, guys, thanks for joining for this video. Give us a like, subscribe for more Cardano and Stoic Pool videos every week. Share us with your mates and other ADA holders. If you have any ADA laying around, consider delegating to Stoic, and I'll catch up with you in the next one. See you then.